Hey everyone, here is a comprehensive overview of Impressico's data engineering and data pipeline framework. But what exactly is a data pipeline? In today's digital landscape, companies generate and collect massive amounts of data from various sources. This data is essential for making informed business decisions, enhancing customer experiences, and driving innovation. However, raw data is often messy, unstructured, and scattered across different systems in multiple formats. A data pipeline automates the process of collecting, transforming, and delivering data, making it structured, accessible, and valuable. Data pipelines come in many forms, covering any process that moves large amounts of data from one system to another. The approach we're discussing today represents a general framework, but there are multiple ways to implement an effective data pipeline depending on business needs. The core stages of a data pipeline. A data pipeline typically consists of 5 key stages: collection, ingestion, storage, processing, and consumption. The order of these stages may vary based on the type of data, but they are generally present in every pipeline. Let's begin at the top. Data collection. Imagine working at a global e-commerce platform like Amazon, where data flows in from multiple sources, including databases, data streams, and applications. Databases such as MySQL, PostgreSQL, and DynamoDB store structured transactional data. For example, every user registration, purchase, and payment transaction is logged in these databases. Data streams capture real-time activity, such as tracking user clicks, searches, or IoT device data. Tools like Apache Kafka and Amazon Kinesis enable real-time event streaming, ensuring data flows seamlessly across systems. With various data sources in place, the next step is the ingestion phase, where data is loaded into the data pipeline environment. Depending on its type, data can be directly fed into the processing pipeline or first stored in an intermediate event. Technologies like Apache Kafka and Amazon Kinesis are commonly used for real-time data streaming. Data from databases is typically ingested through batch processing or change data capture tools. Once collected, data must be ingested into the pipeline environment. Depending on its nature, data ingestion can happen in 2 ways. Batch processing. Large volumes of data are ingested at scheduled intervals, making it useful for aggregating daily sales reports. Common batch ingestion tools include Apache Spark, Hadoop, and Hive. Stream processing. Real-time data is processed instantly, making it ideal for fraud detection and live analytics. Tools like Apache Flink, Google Cloud Dataflow, Apache Storm, and Apache Samza efficiently handle streaming data. For instance, FLI can identify fraudulent transactions in real time by analyzing transaction streams and applying advanced event processing rules. Stream processing operates directly on data from sources, storage systems, streams, and applications, instead of relying on a data lake. This is where ETL or ELT processes come into play. Key processing tools include Apache Airflow, ADF, and AWS Glue, which orchestrate data workflows and automate the processing pipeline. ETL tools which clean, normalize, and enrich raw data, converting it into a structured format ready for analysis. This is the stage where messy, unstructured data is transformed into meaningful, structured insights that businesses can rely on. Once processed, data needs to be stored efficiently for future use. There are 3 primary storage solutions. Data lakes, example, Amazon S3, Hadoop HDFS, store both raw and processed data. Data is often stored in formats like Parquet or Avro, which are optimized for large-scale storage and efficient querying. Data warehouses, example, Snowflake, Amazon Redshift, Google BigQuery, store structured data optimized for fast analytics and reporting. Now that the data is processed and stored, it's time to put it to use. Businesses leverage this data across various domains. Data science teams use tools like Jupyter Notebooks with TensorFlow and PyTorch for predictive modeling. For instance, a data scientist might build a model to predict customer churn based on past interactions. Business intelligence tools like Tableau and Power BI provide interactive dashboards, helping business leaders visualize trends and insights. These tools integrate directly with data warehouses or lakehouses, allowing business leaders to visualize key risks and trends. Self-service analytics tools like Looker empower non-technical teams to query data without needing deep SQL knowledge, making data-driven decisions. S3, Azure Data Lake Storage, ADLS, Gen 2 for Azure, and GCP for Google, making more accessible. The local ML Lockers modeling language simplifies SQL complexity, enabling marketing teams to analyze campaign performance. Machine learning models leverage this data for continuous learning and optimization. For example, fraud detection systems in banks use real-time transaction data to identify suspicious activities and prevent fraud. And that wraps up our overview of data pipelines.